Hello students, my name is Amit Khan. In this video we will discuss about the topic measurement fundamentals of electronic measurements, electronics ETCE 5th semester. The first one is the performance characteristics of an instrument. There are two types of performance characteristics of an instrument, that is static and dynamic characteristics. Static characteristics, it is considered for instrument used to measure an unvarying process condition. All the static characteristics are obtained by one form or another process called calibration. The examples of static characteristics are accuracy, precision, repeatability and reproducibility, etc. Then comes dynamic characteristics. Dynamic characteristics are the characteristics which are changed rapidly with time. That means they varies with time. That is called dynamic characteristics. Like speed of response. Then comes calibration. Calibration is the process for determination of the correct value of each scale reading on a meter or other measuring instrument. There are different steps for calibration. Those are: first, we examine the construction of the instrument and identify all possible inputs. Then we decide which of the inputs will be significant in the application for which the instrument is to be calibrated. Then procure apparatus that will allow all significant inputs to vary over the ranges considered necessary. Then by holding some inputs constant, varying others, and recording the output, develop the desired static input output relations. Then comes accuracy. Accuracy is defined as the ability of a device or a system to respond to a true value of a measured variable under reference conditions. So what is true value? True value is nothing but the difference between the instrument reading and the static error. Then comes precision. Precision is the degree of exactness for which the instrument is designed. Then comes repeatability and reproducibility. Repeatability is defined as the closeness of agreement among a number of consecutive measurements of the output for the same value of input under the same operating conditions, approaching the measurement from the same direction. And reproducibility is defined as the closeness or the degree of closeness of agreement among a number of repeated measurements of the output for the same value of input made under same operating conditions over a period of time, approaching from both directions. So basically repeatability, reproducibility is also a type of precisions. The difference between repeatability and reproducibility is, in repeatability the measurement is from the same direction, and in reproducibility we can approach from both directions. Then comes sensitivity. Sensitivity is the ratio of a change in input to the change in output at steady state conditions. Then comes what is resolution. It is the least incremental value of input or output that can be detected, caused or discriminated by the measuring device. Then comes span. Span is defined as the range of an instrument from the minimum to maximum scale value. Then comes range. Range can be defined as the measure of the instrument between the lowest and highest readings it can measure. Then comes instrument reliability. It is defined as the extent to which an instrument consistently measures what it is supposed to. Then comes dynamic range. It is the ratio between the largest and smallest value that a certain quantity can assume. Then comes what is error. An error or fault can be described as the disparity between the calculated worth and the exact worth. There are different types of error in measurement. The errors in measurement can happen from the various sources, which are generally categorized into the following types. These are clarified beneath in details. The first one is systematic error, then gross error, then random errors. Then we can see in the diagram that systematic error can divide in different types of errors, that is observational error, environmental error, and instrument error. Instrument error can be of three types, that is inherent limitation of device, abuse of apparatus, and effect of loading, that is loading effect. So error is nothing but the difference between the measured value and true value. Then comes static error. Static errors are caused by limitations of measuring device or the physical laws governing its behavior. So it is basically caused by the limitations of the measuring device or the physical laws governing its behavior, while dynamic errors are caused by the instrument not responding fast enough to follow the changes in a measured variable. Then comes systematic errors. These type of systematic errors are generally categorized into three types of errors, that is observational error, environmental error, and instrumental error. Observational error may occur due to the false study of the instrument reading, and the sources of these errors are many. Environmental errors will happen due to the outside situation of the measuring instruments. These types of errors mostly happen due to the temperature result, force, moisture, dirt, vibration, otherwise because of the electrostatic field or magnetic field or magnetic effect. Then comes the instrumental errors, which happens due to some of the following reasons, that is first one is an inherent limitation of device. That means these errors are integral in the device due to their features, namely mechanical arrangement. Then abuse of apparatus, that means instrument happens due to the machinist faults. And then comes the effect of loading, that is called the loading effect. The most frequent type of this error will occur due to the measurement work in the device. Then comes gross error. It can be defined as physical errors in analysis apparatus or calculating and recording measurement outcomes. Then come random errors. This type of error is constantly there in a measurement, which is occurred by essentially random oscillations in the apparatus measurement analysis or in the experimenter's understanding of the apparatus reading. The absolute error is defined as the absolute value or magnitude of the difference between the measured value and the true value. The relative error is defined as absolute error relative to the size of the measurement. All you need to do is divide the absolute error by measured value. Then come percentage error. Percentage error is the difference between a measured and known value divided by the known value multiplied by 100%. Then comes units of measurement. What are the role of units in measurement? A unit of measurement is defined. A definite magnitude of a quantity defined and adopted by convention or by law that is used as a standard of measurement of the same kind of quantity. Absolute units are units of physical quantities selected in a comprehensive scientific system based upon three or more. In a dynamic system, the fundamental units are unit of length, unit of mass, and unit of time. What are the systems of unit? As we know, three systems are CGS, FPS, and MKS units systems. There are 7 basic units in the SI, that is meter, kg, kilogram, second, Kelvin, ampere, mole, and candela. Then comes standards of measurement. It is a physical representation of a unit of measurement. Standards are always arbitrary. To ensure that testing equipment stays within an acceptable range of accuracy, measurement standards are used. A measurement standard is the point of reference to which the testing equipment refers. From international standard, comes primary standard, from primary standard comes secondary standard, and from secondary standard come working standard. International standards are defined on the basis of international agreement. It represents certain units of measurements. Primary standards are basic standards which represents the fundamental units and some of the derived mechanical and electrical units maintained by National Standard Laboratory. Then come working standards. Working standards are basic reference standards used in the industrial measurement laboratories, maintained by particular industrial measurement laboratories. Working standards are the principal tools of a measurement laboratory, used to check and calibrate general laboratory instruments. IEEE is the Institute of Electrical and Electronics Engineers. IEEE standards are used for testing and evaluating various measurement systems and components. Thank you all for watching this video.